Natural transfer fluxes between the slow and fast pools of carbon occur via seafloor sedimentation and also through rock weathering on the Earth's surface. But these fluxes are quite small, so about 0.2 gigatons of carbon per year. And this is in comparison to the relatively enormous fluxes between reserves in the surface spheres. So about 120 gigatons of carbon per year move between the atmosphere and the terrestrial biosphere, and about 90 gigatons of carbon move between the atmosphere and the ocean. I spoke about photosynthesis and the way in which energy gets stored in organic molecules on short timescales. And when these organic carbon molecules get stored in the geosphere through the processes of sedimentation over really long periods of time, so tens to hundreds of millions of years. So the organic carbon that's stored in sediments over very long timescales, hundreds of millions of years, we're actually digging that carbon up as coal or extracting it as oil or gas and using that to fuel our civilization currently. And as we all know, this is releasing large amounts of carbon back into the atmosphere, so we're perturbing the natural carbon cycle. Anthropogenic emissions of carbon, although significant, are still dwarfed by those natural fluxes that I spoke about. And so anthropogenic carbon emissions to the atmosphere are redistributed through the carbon cycle. So approximately a third will go to the atmosphere, a third will go to the terrestrial biosphere, and a third ends up absorbed by the oceans. Because of the slow rate of carbon transfer out of the surface spheres by weathering and seafloor sedimentation, the carbon that we're emitting into the atmosphere will take a very long time to be removed from those surface spheres, on the order of hundreds of thousands of years. Some of the critical questions are, will the ocean continue to take up carbon as it warms? So the solubility of carbon dioxide decreases with increasing temperature. So as the ocean begins to warm, at some point in the future, the ocean will actually become a source of CO2 to the atmosphere as opposed to a sink. And so this current negative feedback will actually become a positive feedback. So understanding these complex feedback mechanisms is a really important part of climate modelling and future predictions.